Here we are going to discuss about the portion what are electromagnetic waves, discuss the momentum and energy of electromagnetic waves. Also, obtain Maxwell's equations in vacuum, explain how Maxwell's equations lead to the prediction of electromagnetic waves. These are the two essay questions that we are going to expect from this portion. First of all, electromagnetic waves. Electromagnetic waves is a form of energy emitted by moving charged particle. As it travels through space, it behaves like a wave. The creation of all electromagnetic waves begins with an oscillating charged particle which creates oscillating electric and magnetic fields. Actually, this electromagnetic wave is a transverse wave with a perpendicular electric and magnetic fields by oscillating electric and magnetic fields both in perpendicular direction, and the propagation of the electromagnetic waves is in a direction perpendicular to both these electric and magnetic field. So the electromagnetic waves have energy and momentum that are both associated with their wavelength and frequency. Then the velocity of electromagnetic wave is equal to the velocity of light. The wave equation for electric and magnetic field. Before going that, let's discuss the Maxwell's equation in free space. Already you have studied about Maxwell's equation. So Maxwell's equation in free space, del dot E is equal to 0. We know that del dot E is equal to rho by epsilon 0. This was the Gauss law. In free space there is no charge. Rho is equal to 0 and hence del dot E is equal to 0. Then next del dot B equal to 0. Del cross E is equal to minus dou B by dou T, and del cross B is equal to mu 0 epsilon 0 dou E by dou T. Then we have to develop the equation for the electromagnetic waves. So that means we have to develop the wave equation. Wave equation means the differential equation, second order differential equation relating to space and time. That is dou square psi by dou t square is equal to 1 by v square by dou square psi by dou z square. We have to find a relation similar to this. For that we are taking the curl of the equation. That is del cross E. So substituting we will get del cross E is equal to minus del square E. Using 3 in equation we will get del cross E is equal to minus dou B by dou T. That is del cross minus dou B by dou T is equal to minus del square E. Therefore we can write minus dou by dou T of del cross B is equal to minus del square E, and using this we can write dou by dou T del cross B is equal to mu 0 epsilon 0 dou E by dou T. Substituting the value here, we will get dou by dou T of mu 0 epsilon 0 dou E by dou T is equal to minus del square E. Finally, we will obtain the relation del square E is equal to mu 0 epsilon 0 dou square E by dou T square. Or rearranging, we can write this as dou square E by dou T square is equal to 1 by mu 0 epsilon 0 into del square E. That is 1 by v square dou square E by dou T square is equal to dou square E by dou Z square. That is the classical equation for wave motion. Similar procedure, we will get the equation for B as del square B is equal to mu 0 epsilon 0 dou square B by dou T square. Thus, we have separate equation for E and B, which are second order differential equation. Comparing this with the classical wave equation, that is dou square psi by dou Z square is equal to 1 by v square into dou square psi by dou T square, we can write it as del square psi is equal to 1 by v square dou square psi by dou T square. That is in 3 dimensions. Del square psi means dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square. That is in 3 dimensions. Here 1 by v square is equal to mu 0 epsilon 0. So v is equal to 1 by square root of mu 0 epsilon 0. Substituting the value of mu 0 and epsilon 0, we will get the value of velocity v is equal to 3 into 10 raised to 8 meter per second. This was coincident with the experimentally obtained value of the velocity of light. James Clerk Maxwell obtained the theoretical value for the velocity of electromagnetic radiation as 3 into 10 raised to 8 meter per second. This implies that light is an electromagnetic wave. This brilliant prediction was proved experimentally by Heinrich Hertz in 1888. Thus, when you are asked to obtain the wave equation of electromagnetic waves, you have to first write the Maxwell's equation in free space, then take curl of E and curl of B, then obtain the wave equation, then compare it with the original one-dimensional wave equation and find the velocity of the waves, and thereby state that the velocity of electromagnetic waves is coincident with the velocity of light.